One of the deepest questions for humans to ask is, what are we and where do we come from? And now we are gearing up in my laboratory to search for the first steps towards inorganic evolution, which would explain the origin of life.
ChatGPT is alive?
ChatGPT is alive because living systems produced it. ChatGPT cannot exist in the universe without human beings. The tech guys and a few untrained philosophers are just making stuff up because they want to point themselves to new religious leaders. I think all this talk that we have an impending AI doom is absolute stupidity.
Who are you?
I'm Lee Cronin.
Tell me a bit more.
I'm a Regis Professor of Chemistry at the University of Glasgow and also the CEO of Chemify. I'm interested in understanding what life is, making life in the lab, building a chemical search engine, and finding out what's in store for for humanity and the rest of the universe.
And what life is?
And what life is, yeah.
No, what life is? This is a question.
What is life? I don't define. That's a very deep question to start with. I mean, I think the simplest answer to that question is life does complex things at scale. And that means makes complex molecules, makes technology, undergoes evolution, is able to build architectures that is not possible without life. So the life creates a lineage of information, in context information, and life has found out how to use resources in the universe to build a never-ending seeming road of complexity, seemingly in the face of what we think is thermodynamic extinction, which I probably think is not correct.
What do you mean?
So the second law of thermodynamics kind of says that, the universe is going to ultimately finish in a heat death, right? And I think that life seems to do something that we don't quite really understand. It seems to create knowledge. Living systems are not, through human beings. I guess you had to start with the origin of life, then multicellularity, animals, then the beginnings of consciousness, abstraction, and then technology and culture and language and mathematics. But now we have that culture of mathematics and language. We're able to generate knowledge that we can pass from one another, that allows us to do even more exceptional things than we were before, and that seems to be counter to the second law of thermodynamics. I'm not saying it breaks it, because I just think we don't know what the second law is. Not really a law; it's just a tendency, an observation. But we also have the law of complexity, which is what we see living systems doing.
I'm a bit confused.
So what's confusing you?
So let me try to rephrase what you said about the law of thermodynamics. You said that is the law of thermodynamics is not saying anything in particular, just that is here. The world is getting towards getting heated. This is what you said, and this is not viable.
The second law says that as that things go from order to disorder globally over the universe. So that we observe hot things cooling down, ordered things become disordered. But that's not all the story. That's what physics does. Physics and statistical mechanics, hot gets cold. What biology seems to be able to do is create complexity. Now, it doesn't break the second law, but it somehow mines order from energy. So the sun is the source of a lot of the order on Earth, because we get all this energy for free. That energy heats up the Earth. It also, through light, we're able to do photosynthesis. And the engines, the biological engines on Earth are able to produce, sugars for life forms, right? Carbohydrates. And that fuel, that chemical fuel, is actually energy from the sun. But that energy from the sun ultimately ends up in humans being able to produce technology. I just think it's super interesting that we obsess in science, in physics in particular, about the order to disorder, but we don't and we understand that using statistical mechanics, but we don't understand the disorder to order. We don't understand that at all. That's the gap. That's what I mean.
And where is this phenomenon happening from disorder to order?
Well, it seems to be that life is is not just an order producer, it's an information, a complexity producer. That life is able to create architectures, machinery that encode information. And that is, the secret to life is hidden in that transition from the dead, inanimate, information-free world to a world where living systems are exchanging semantic information, which I think is super interesting.
So what do you think is life? What do you consider life when you say life?
So I think life, when we try and talk about what life is as a thing, I think that's hard. Life is a phenomenon. So I think living systems are characterized by living systems are produced by evolution. And evolution, we should be careful to explain that there is evolution before life, whatever that is. We don't really fully understand that. But at the origin of life, after the origin of life, we have evolution. And it looks like you have this chain of events of living things, animals, culture, technology, and living things use that lineage. Now, a living system, you could have some characteristics. On Earth, living systems are cellular. They contain genetic information. They have a metabolism. They have all these features. But if you start turning the question about what life is into a series of definitions, you start to lose something which I think is super simple and characterizes living systems uniquely from non-living systems. That is their ability to do complex things at scale. And I think that's a very, very important recognition that we've only just started to really begin to understand through my work, my collaborators, and a few others in the last few years.
ChatGPT, it's alive? It's live?
Yeah, so it's evidence of life insofar as ChatGPT was created by human beings, number one. Number two, the data that produced ChatGPT is produced by human intelligence it's the internet. So if the internet has captured information of all humanity and culture, then it would be no accident to assume that ChatGPT is alive because living systems produced it. ChatGPT cannot exist in the universe without human beings.
So it's not alive.
It's evidence that the lineage of life. I would say it's not alive, but it's life. And I think I'm alive, you're alive, maybe animals, plants are alive. My mouse is evidence of life. This mouse could not exist without life. Same way, a virus outside a cell is life, evidence of life. A virus in a cell is alive because it can replicate itself.
But if there is a robot that makes other robots and makes stuff, then it's alive?
Yes.
So the property of making stuff is what is the factor of being alive or not alive?
It seems to be. I mean, that's just the first kind of realization that I have that is a unique The thing is, if I say, okay, living systems have to have, just energy, metabolism, cells, and all these things, you can find counterexamples where people get confused. So I think that this understanding of how machinery, whether it's produced by evolution or technology, is able to create other machinery. I mean, right now on planet Earth, we do not have any robots that can make other robots. The only way we can get robots to robots is with human help. So we have no autonomy. So there is this other special word that basically, if the robot was able to autonomously make other robots, say on the moon or something, use the resources of the moon, then I'm guessing that will be a very special technological event. Because one of the things we might want to do is for our technology of Earth, everyone talks about human civilization and human culture. I think we should think about Earth culture and Earth technology. Wouldn't it be great in the future if Earth culture and technology could leave Earth, populate the solar system, go further afield? So it may not be human, but it will be Earth originated from Earth technology.
Okay, so I want to ask some dumb questions. I already asked some of them, but I will ask a bit more. So are you ready?
Go.
What is chemistry?
Chemistry is the study of electrons around atoms. So that's what all chemists do. Chemists are obsessed with controlling reactivity. So chemists touch electrons around atoms all the time, whether they're basically splitting water into oxygen and hydrogen, whether they're making a new drug or making a plastic or a battery. Chemistry is about electrons connected to atoms.
And why you think chemistry is not as sexy, let's put it that way, in the scientific community, like philosophy or science?
I think chemistry is hard, and also chemistry is quite messy and conceptually difficult. And also chemistry is not just a hard science, but it is a very creative discipline where you have to bring together the ability to do lab work, to do mathematics, to do quite hard memorization of some reactions, right? It's kind of in the middle. But I think chemistry is sexy. I mean, if you look at the Breaking Bad, maybe that's not the correct, that's pretty cool, fun. And also, the current kind of science, fiction where we're chemists out there, So I don't know if it suffers that much, but I would agree that compared to natural science or philosophy, maybe for some aspects of thinking about what is going on in the world, chemistry suffers from it's not seen as deep or fundamental. Why are we here in the universe? What is going to happen to the universe at the end? But that's because actually physicists have been very good at occupying that space. I guess in some regard, the hardest question, one of the deepest questions for humans to ask is, what are we and where do we come from? And that's a chemistry question. Now, it may not be a chemistry question at the beginning. I think it's a question that embraces it. It's really a question about, deep philosophical ideas and beliefs. It brings together physics, computer science, evolutionary biology, as well as chemistry. So you have at least five disciplines all working together. But the medium through which, the substrate through which, the stuff through which life exists is chemistry. So I would say that chemistry, if it's not yet reached maximum sexiness, it will become pretty sexy with this question. If people start to think about alien life, what we are, what's happening in the future, how do we improve biology, how do we clean up the planet, how do we get access to clean water, clean fuel, and also how do we reduce aging, maybe even stop aging. These are all fundamental chemistry questions.
Can you touch a bit more on the origin of life involving chemistry that you say is fundamentally a chemistry question?
Yeah, so I mean, I'm not. I think the principles that give rise to life may be at the intersection between certain aspect of physics and chemistry, but I don't think you can make a living system without chemical bonds. Chemical bonds are required to store energy and information. And really, if you want energy and information and also the ability to move, motility, then you need chemistry for those. So at the origin of life, somehow the inorganic world had to make this transformation into this system that was able to have energy, information, structure, and some ability to move around, even if it was to harness the local wind or something like this. So the origin of life was a transition in those functions to suddenly be able to do all those things at once. And that's why we don't understand what happened. There's lots of theories, there's lots of people arguing about it, but really we have no idea what the mechanism is. But it's quite exciting, right? Because it's a bit like if you were, if you imagine in the 1500s, if you were to look up in the sky and say, why is the Earth going around the sun? What is the mechanism? No one would have been able to give you a mechanism, but today we know the mechanism. We can use the mechanism. We can see how light is bent around the star, right, with this mechanism. So I think that
sorry for cutting you. How light is bending around the star, is this chemistry? Or
no, I was making an analogy. I was saying
no,
physics,
I know, but I just wanted to see. So it's not chemistry how to study how the light is going and the.
No, it's physics. It's optical physics.
Okay, sorry about that. Continue.
No. No, I mean, I was just saying, it's the kind of like, it's, I'm saying a few hundred years ago, we had no idea how certain aspects of physics worked, but then we suddenly were able to, there was a series of events. I believe the same thing is going to happen in chemistry.
So how you think we should go about to answer the question, what was the origin of life, why we're here, and how that did it happen? What do you think we should do?
I think my personal approach is really not to think about the origin of life, because that's a historical question and quite hard to imagine the precise conditions, but to think about how we would create an origin of life. And I think what we're trying to do is really create those conditions on the lab or see what's happening in the solar system or elsewhere in the universe, and basically figure out, what were the contingent, the accidental conditions that allowed evolution, which is, I think, has a general description in the universe beyond biology. I believe that evolution happens before biology, or there's a fundamental fundamental evolutionary principle that doesn't need biology, and it's not woolly, it is concrete. It's to do with information storage in the universe and actuation, just like in biology. But actually, I mentioned this in a paper I published a few weeks ago, and everybody went crazy. The entire internet went crazy. It was very funny. I was not expecting the evolutionary biologists to tell me that they owned evolution. But I guess that was inevitable. They're evolutionary biologists. It's a bit like me as a chemist being told by a computer scientist that because they can simulate chemistry in a computer, they owned chemistry.
So what was their reaction?
Their reaction was very, I would say, negative. And it was an emotional reaction. And then when I pointed out that it was emotional reaction gently, they still dug in and said I'd used the word evolution incorrectly, where I have used the word of evolution absolutely correctly. Evolution is about change. Biological evolution is about change in biology, right? So if I talk about evolution outside, and don't qualify it with biology, I would naturally say it's more, I'm doing something outside of biology. But, I could have been clearer. It's always good in science to be as precise as possible, so as many people can understand what you're doing, talking about. And there's this balance between precision to aid understanding and being so precise that you have to use so many qualifiers that no one understands what you're saying. Because if you say, I'm going to look at the full moon on a Tuesday in a even year when it's, this time, you can keep adding specification after specification, and in the end that becomes that loses meaning. So in science, when you're trying to explain to people what you've done, you want to be as simple as possible and as fundamental as possible. And I thought I was being both simple and fundamental, but I didn't realize I was being incredibly controversial because people had ownership over the word.
Yeah. Just for me to understand, because it sounds like this is a big deal for the scientific community to say that evolution came first of biology, right? This is what you say. Can you explain me again a bit more to just fully understand what you mean by that?
Yeah, so what I think more precisely is the process of selection that came before biology as we know it, and that there was, in the universe, there are physical processes occurring which are not lifelike at all. But what happens over time is the process of matter interacting with other pieces of matter can cause objects to be created and destroyed. And that act of creation and destruction causes the potential for making interesting new objects, in this case molecules. And if those molecules happen to be quite good at helping the production of other molecules, then you can get networks of interactions. Now, if you can start to have populations of molecules in different places and they can compete with each other, and one population of molecules is better selected by the environment to survive in a population of different networks, then the persistence of that through some copying process, catalysis in this case, can allow you to set up a dynamic which looks very similar to biological Darwinian evolution, which is, the process of, adaptation and selection, survival of the fittest by natural selection. And I guess what I'm saying, there is a survival of the fittest by inorganic selection. So inorganic selection happens before natural selection, because natural selection is where the biological world is and you have ecosystems. And so before biology, the inorganic world was able to start going up that complexity ladder, that evolutionary ladder, using the force of selection and evolution.
So this is similar, maybe this is completely stupid observation. Like you were explaining me, I was thinking like the chicken and egg problem. Like who came first? Is it like a good analogy to put on this?
I can answer the question. So what came first, the chicken and the egg? The answer is both of them did, but simpler versions. Much simpler versions. So very simple chicken, very simple egg. That increased in complexity, that had to coexist together. In fact, the chicken and the egg at the beginning were the same thing. And this chicken, and of course, the egg is part of the life cycle of the chicken. So if the system didn't randomly produce the egg, and from which the egg produced the chicken, and the chicken was able to then undergo maturation and become an adult, that chicken would lay no eggs. So the lineage of egg to chicken to egg to chicken to egg would not exist. And it's the same question as what came first, the caterpillar or the butterfly. Caterpillar has to make a transformation into a butterfly by morphogenesis. Now, the caterpillar is different to the egg because the caterpillar is a living thing eating around. The egg is pre-birth of the chicken. Or the chicken is just being, going through its gestation period. I'm not sure if gestation is the correct word, but its growth period in the egg. So I think, what came first, the chicken and the egg, is a category error. They came first. They were both together. They had to. Of course, in time, chickens lay eggs. Eggs take some time. But indeed, an egg without a chicken can't even hatch because it's not going to be warm enough. So to make a functioning egg, you have to have your chicken on the egg.
I understand.
Me too.
So I have a question. You said that you're trying to create an origin alive in the lab. Did you ever came close?
We've been trying to do this now, thinking about it for 13, 14 years. I've been learning a lot and training a lot of students and postdocs and getting money to build technology. And the way that we've been thinking about it is I needed to build a kind of robotic system for chemistry. So this is why I had to build a programming language for chemistry. And I needed to build the programming language and the technology. And then that's great. So I have this kind of experimental setup. But until very recently, in the last 3 or 4, maybe 5 or 6 years actually, I wasn't really sure what I was looking for. And so the problem was, although I wanted to make a life form in the lab and have done for, like I say, since at least 2010, if not a bit longer, I didn't know what success looked like. And so that's one of the reasons I had to develop assembly theory to say, well, hang on, what does characterize the difference between a living and a dead thing? And I think now assembly theory, certainly in my lab and a few other labs, we know how we can use assembly theory to characterize the degree of selection and evolution and quantify it even. And that now we are gearing up in my laboratory to build a selection engine that uses assembly theory to search for the first hints, the first steps towards inorganic evolution that may then bootstrap to a new biology, which would explain the origin of life. And I think actually in the end, it's going to be so simple to show that's going to be kind of insane because, lots of people say, oh my God, the cell is so complicated. How can you possibly get to a cell? And, the creationists use that as an argument that the cell is just too complicated to have formed without, some direction. Actually, that's going to be pretty trivial to prove to be wrong. And that inorganic evolution is more than capable of generating the complexity that we require to produce biology. And that's we're doing it right now. It's super exciting, but it's hard work, right? These engines have to run for a long time. We have to do chemical analysis. We have to write computer programs. We have to put analysis, real-time analytic systems on there. There's mechanical engineering, electrical engineering, and also fundamental physics. So there's quite a lot of disciplines I have to bring together to do this.
So you think you are going to come up with an answer similar to going to be a chemistry answer? Like when you put this and this and these molecules, this happens?
What really excites me, I really don't know. I guess the answer will be somehow embedded in chemistry, like we'll be watching molecules evolve, complexity. If we're lucky, we might see the emergence of cells, right? Very primitive cells. But what I think would be really, I don't predict this, I hope for it. If we could turn an inorganic chemistry system into a cellular system that has some primitive metabolism, a primitive genetic material, and a primitive kind of factory protein-like thing that could spontaneously emerge, and critically, the system could copy itself and undergo natural selection. That jump, I think, will be a major transition in our science. And so for me, that's what I would like to kind of focus on doing.
What this will do to the world if you actually find this?
What will it do for the world? I think it'll be great for the world. It will allow us to understand that we aren't flukes, that there is a phenomenon that produces humans. It will allow us to pinpoint more carefully in the universe where to look for aliens, evidence of, alien biology. And also it might help us come to terms with what life is and going to become in the future of humanity. Everyone right now is kind of dooming, saying, oh, we're going to die of climate change and nuclear war and AGI. And I think that's just simply not the case. I think that life is absolutely determined to survive on Earth, and life will generate as much novelty as it can to keep the human race and our future humans or future cybernetic creatures in the business of creating an optimistic and forward-looking future.
So this will be a big deal, and you are very optimistic about the future, as I understand.
Yeah. I mean, life started on Earth, right? Somehow. And we are evidence that happened. So I'm very, excited about the prospect of being able to attempt to make the life. Many people say it's too, we have to be very lucky. It's going to be very difficult to understand all this stuff. And my feeling is no. My feeling is it will be pretty obvious.
Because we think that we are complex.
Well, we are complex. I mean, we are complex from our culture, from our technology, from ourselves. I mean, that we are complex. I mean, whether we're the most complex things in the universe, I don't know. But the human brain is certainly the most complex architecture in the known universe.
So you think when we make this, we can send some stuff to Mars and just allow them to evolve, and then a life that we created, we send it to different planets and stuff? Like how?
I would love to terraform Mars, not for humans, but just to terraform Mars to be minimally hospitable for a new synthetic biology that we can create. So we evolve new Martians. I think that, life on Earth is not very well suited to life on Mars. Elon Musk may disagree with me, but, we need to change the environment on Mars to make it better for the living system we're trying to put on there.
I watched the Lex Friedman podcast that you did some time ago, and I think that you said something very important, that Lex didn't pay that much attention to it and didn't elaborate that much on the podcast. You said that the goal is to increase the fun of the universe, and I want you to touch a bit more and elaborate what you mean by this.
So I think the universe seems to be becoming more and more creative. The more technologies we are developing, the more things we do, the more knowledge, And I think that for me, it would appear, if I'm being very optimistic and fun about the future of the universe, it would appear that the universe is creating more knowledge through selection. It's getting more of an interesting place to be, not a less interesting place. And I think that that's a really interesting observation, that why is it that our universe, as far as we know, looking at our planet, is just creating so many interesting things. I mean, it doesn't take someone, that much convincing if they go out to a party, I don't know, somewhere open air, maybe go in San Francisco, or maybe like, so many different people, different cultures, art, philosophy, everyone writing things, everyone trying things. Humanity expresses something about biology that is really interesting, and that is our creativity. So I'm pretty interested by that.
Yeah, but you didn't explain me what you mean. The goal of our goal is to increase fun.
Yeah, I mean, I would say the goal is to increase curiosity and functionality, and of course, that's fun. I find for me, what makes things for me worthwhile is being curious and asking questions and saying, why did that happen? And so I think the universe, to be a fun place to be, has to keep giving me new science secrets. What new discovery can I try and make tomorrow, the day after, the day after? So
I want to stay a bit more on this topic. I want to dig deeper. So I have when I was thinking about all these whatever philosophical questions, I came up with my rule of life is that anyway you cannot control so many things. Like if you have a child and like you parent it in a certain way, he can turn out to be, if you have the best parenting, he can turn out to be the worst kid. It's not always the best thing that you can do. So a lot of times it's like just choose the fun scenario for you. That's always the best thing that you can do in a way in your life. So I'm not sure if you agree or disagree, or like you have something to say about this thought that I had.
about what, parenting?
Not about parenting, it's that always choose the what's the rule in life to have more fun.
Okay, I mean, okay. Let's unpack. So yes, it could be that. How do I have more fun? That's by being more curious, and maybe that comes about by selection, making sure that I'm capable of surviving. So maybe fun comes from the interplay of me exploring the universe, fun, being curious, and if I can do random things in the universe, it's like I can find dangers and find new knowledge. So new dangers I can avoid, new knowledge I can get new technology to help me persist longer. So that my selfish gene, if you like, is optimizing my fun seekingness, but to be curious, to make sure I'm absolutely loaded with all the information and all the capabilities to survive any adversity. And that could be, the root cause, that all the fun in the universe is just to ensure continued existence.
But you think the same way that you are having fun, the curiosity, an artist, for example, is the fun of him is like just creating more art?
Yeah, I think so. And that's the way they explore their universe, right? And try and make sense of their sensory environment.
So it's good to put as rule of our lives, let's increase the fun of the universe. Let's increase the fun of our lives. Always when you have a decision to make, just you see, what will be more fun to do? More fun would be to become a YouTuber or to become like a businessman or something like that. Like
I have a great deal of sympathy for that. I think creating, I would call it mischief, not just fun. I often try to be unpredictable in my life, not crazy, not like not like doing stuff that's dangerous, but it's to try and basically, I don't know, like to confuse people by doing things they weren't expecting, right? To get them thinking in new ways, to get them searching for new things, to get them questioning things they didn't question before. I've always been like this since I was a kid. So when I wake up every day, I try to do something different. The problem is as you get older, you've seen it all, right? Your working memory decreases, not because your memory decreases, just because you know more and more and more and more and more and more. When you're a kid, you know nothing. So you can just do everything. And so what I try to remind myself is like, and I think it confuses my academic colleagues, that I'm very good at being free from knowledge. And that drives some academics crazy, because some academics I know are gatekeepers. They thrive on telling everyone how much knowledge they have, whereas I explore by telling everyone how little knowledge I have. And I'm a discovery scientist, so and it's not that I don't know anything, it's just that by removing my prior conditioning, I can just find novel things more quickly. Sure, I may not be able to focus on something. Maybe if I'm going to make a particular machine or look at a particular phenomena, it might be that that's not the perfect way to do it. But I think that's where my love of curiosity and being a little bit crazy comes from. Just this willingness to just mess things up a little bit.
How do you exactly keep up with, like, you keep reminding yourself every day that I don't know anything, I know so little? It's like, and then you believe yourself and then you act accordingly, or like you have one person to tell you that you are stupid or something in some stuff. I don't know.
No, I mean, I don't know. I mean, well, people tell me I'm stupid all the time, but they do it indirectly, which makes me kind of sad. No, I like to ask questions and I want to get to the answer. And I have a framework for understanding the world that I'm challenging all the time and trying to make better. So by interacting with, it's not about people telling me I'm stupid. It's about people telling me that this is the framework they use, that why am I using that framework? We make comparisons and I can say, well, why did you do that? Why not that? Which is more fundamental? And so it's really about exploring the phenomena in the context of seeing what was happening, right? And then just, I have an ability to ask questions that other people wouldn't ask because they're too obvious, or they just seem too trivial. But I really mean them. And maybe that is a stupidity thing. But you know what? I'm even getting told off by people now who think when I say that I'm stupid, that it's a pretend stupid. So I'm just like, so it's kind of annoying. I mean, basically, I think we should say not stupid, but willingness to not say too much. I know enough to not take what I know and put that before the observation or discussion, an idea, right? It's really important to observe things with an open mind and then try to then figure out from first principles what has happened, rather than to pattern match and impose a pattern that you've seen before to convince yourself you have a high level explanation.
So the people who are making, where they are very certain with their observation, they don't know enough.
Yeah, I think the people that basically are telling you they are certain are almost certainly not certain.
Yeah, I think you are very right on this, because a lot of times when you become cocky, for example, I'm a YouTuber and I make YouTube videos and I get on my entertainment channel millions of views, and a lot of times when I become cocky and I see that I know this stuff and all this stuff, then I stop learning. So it's like, it's this cycle of ups and downs when you then, yes.
Just my family have just come in, so I was just shutting the door because there was some noise.
Not a problem. We're going to keep it in this. The people like to see this stuff. So yes, so I was just encouraging what you were saying, that I think is correct to say that to convince yourself that you don't know because a lot of things, because when you think that you know everything, you limit your learning and your potential.
I mean, the thing that I'm doing at the moment is I realized I didn't know any philosophy that was aiding my ability to pass information about the world. And just recently, I've been reading a lot of philosophy, And that philosophy is actually helping me reframe things and understand things and ask even more interesting questions. And I realized instinctively I was asking those questions for the right reasons. And, for instance, I always have a horrible, I hate people who tell me about probability of things that have never happened, right? So probability of an AGI, probability of aliens visiting Earth, probability of, things that have never happened before. And the problem with that is that if something has never happened before, you can't put a probability on it. That doesn't mean it's not impossible. It's never happened before. However, if you know that, 1 in a million swans is black, and someone says, you're going to see a swan, what's the probability it's black? You say, 1 in a million. Whereas, that makes sense. And this is I realize that there's a philosopher, Karl Popper, that I started kind of reading because I was trying to make sense of David Deutsch, who's a very interesting philosopher, and he's a physicist, actually. And at the beginning, I was like, I have no idea what you're talking about. Sounds nonsensical. So then I tried to work out where he got his ideas from and how he's framing things. And then I started reading across all the different philosophers, and I suddenly realized that there was an additional, I'm very curious, but it was really haphazard. Chemists don't get taught natural philosophy. And then I realized by using these frameworks, I could actually position my curiosity and my intuition and then challenge it in the correct way. Because actually, your intuition lies to you because your senses tell you what you need to survive. So I had some fun doing that. So I think that where I am now is I'm more equipped to maximize my stupidity because of my new framework for asking questions, which I think is really cool. So I'm like questioning everything again.
So I think a lot of people, me included, consider you very clever. So how do you learn stuff, Mr. Clever?
A lot of the ways I try and learn stuff is I'm not very good at reading something and then understanding it and pretending I know it. So what I do is I build stuff. I build experiments. I build computer models. I build neural networks for fun. I build selection engines. I build interactive computer programs that interact with material. So I have a workshop, and I've always been taking things apart since I was like 5 years old. I used to be banned from having a screwdriver because I had a screwdriver, everything would be taken apart. And the way I build theory is by building experiments. So I cannot think. It's kind of funny, right? It's like I really can't think. But when I'm using my hands in my workshop, I can think. And I'm like, I'll try that now. I try that. I think about that, have a new idea, build it, check. So I do that a lot. And that's how I harness my curiosity in the framework of kind of interrogation of the world. And sure, then I have a bit of intuition. So there's a lot of times where I would, a lot of the technologies that I built that go into my company, I kind of built, in my workshop at home, right? A lot of the new experiments in my research group I built at home. And then I would go in and I would talk to my team and say, what about this? And they would say, oh no, they would then go away and play with it, or they have their own idea and say, no, that's not good, this is good, and we interact. So it's kind of like a collaboration of kind of ideas to say, well, why does this work? So that's how I do it. It's like I'm clever in the past. It's really annoying. It's like when I invented assembly theory, I had no clue. Some days I would not understand the equation. It's like earlier, a few weeks ago, so it was published a paper, and someone's like, how do you derive the equation? I'm like, well, actually, it kind of just fitted the framing, and then I rigorously derived it. And then my team made me derive it because they were like, this equation is nonsense. Come on, prove it. And I was like, oh. So I had to then, I had to build all the exponentials from scratch, play around with the factorials, play around with the mathematics and the representation, and then look at the weighting scheme. And then I realized there was two fundamental limiting principles in exponential in the combinatorial theory and what I was seeing in reality, and I was able to use those. It kind of got me thinking of how maybe E equals mc squared was derived, right? Because at the moment, if you look at electron, so if you look at an electron at rest mass, you can measure the mass of electron. But if you accelerate the electron through a field, it gets heavier, right? And the amount of energy you put in, it gets heavier because it can't go faster than the speed of light. So all you really needed to know is the speed of light is fixed. How the mass of an electron changes and how you accelerate for a field. And you could kind of deduce E equals mc squared and then rigorously then build that framing and then actually deduce it correctly, or using more fundamental reasoning rather than kind of epiphenomena or something like, things like measuring relative relationships with instruments. And so with assembly theory, I was measuring relative relationships with instruments, mass spec, NMR, infrared, copy numbers, exponential explosions based upon the paths and so on. So some days I'd understand it all, be great. And other days I'll wake up and I got no clue. And so what I had to do is build new models. And then I got to a point where I can remember in the past when I understood it. And then I was like, okay, so I just used to have to remember when I understood it before. And then, okay, the understanding gets easier, but it's so hard, right? I mean, I know some real geniuses. They're real geniuses. And it's kind of intimidating how they do it all in their head. Whereas my understanding is it's almost it's like hybrid reality where I have to put my thoughts into the material. I'm almost like, if I had any skill with my hands, I would probably be a carpenter with woodwork or metalwork or something.
So you think even Einstein did some similar process to you, that he was...
I mean, look, Einstein was there's no comparison. Einstein was probably one of the greatest geniuses of the last...
No, I mean with the learning process.
I'm not... So I think what Einstein did, which I'm kind of inspired by, I would like to kind of not necessarily emulate, but I see some parallels with how some people think, is Einstein really... He didn't go mathematics first. He went phenomena first and reasoning, and he thought very deeply about simultaneity, about clocks. If you think Einstein did lots of really deep things, like Brownian motion was the way for him understanding the molecular thesis, the photoelectric effect, all these things. And then thinking about clocks and trains and timekeeping and relativity allowed him to come up with those theories. And so what he did is I think he played some games, right? In a similar way. Thought experiment on a train, beam of light on a train, another train coming towards him, what would happen? And I think, and there are a few insights he could play with, right? If he assumed, knew that the speed of light was fixed, then that suddenly then starts to open up all sorts of ideas. And so I think that people think in different ways, but I'm not like, I don't follow the consequences of the mathematics. I follow the consequences of my thought processes that I then embed in mathematics, and then I then see if the mathematics works. So the mathematics comes later. So I know some people are mathematics first and they just put math on everything. But I think if you're looking for fundamental aspects of reality which haven't been described yet, if you're using math, you're going to be labeling things that already exist, and therefore you're not really going to find what lies underneath. So assembly theory was never going to come out of math first. Assembly theory was going to come out of where do complex objects come from? And is complexity encoded in the object uniquely? Can you tell? And that's where we realized that assembly theory kind of was a thing, and complex molecules have an intrinsic complexity that you can measure. And when I realized that, when I did the experiments and we actually saw it, then I was like, okay, this is a new feature of reality. We should run with it. At the very least, it's a new feature. It could be esoteric and boring and all this, but and so that's kind of how we play around with it. So that's how I play around with it. And I like to interact with people who think in different ways to me, and we can kind of help each other. Because, science is very collaborative. You can have ideas, and you should be brave when you have the ideas. Don't let people tell you wrong unless they can tell you why they're wrong. Lots of people say that's wrong. Why? Because it is. Well, no, that's not good enough. Why is it wrong? Tell me why it's wrong. If you can't tell me why it's wrong and my intuition wants to run with it, I'm going to keep running with it until you can tell me why I should no longer run with it. And then when you tell me why I cannot and why it's wrong, okay, I'm very happy to say, oh, I'm sorry, that was silly, and we try again. And that's really what science is about. And so I think it's very important that we convince people when they're told they're wrong. This is advice I give to myself and young people. Like, I like to come up with outrageous ideas that make people tell me I'm wrong, right? And if I get 10 people telling me I'm wrong, and they all tell me I'm wrong for the same reason, probably I'm wrong. But if the 10 people tell me I'm wrong, but they can't give me a reason, they all give me different reasons, probably I'm not entirely wrong, right? And there's, where you find conflict, you can find interesting problems. And I didn't discover that. That's an obvious thing in science. It's very risky. You have to be brave. That's why my ability to not be too upset with my limited intellectual power, I make up for with my ability to kind of not give up.
I'm a bit curious to understand a bit more, because you have so many things that you said that you run a team, you are writing papers, you're doing collaboration, you're doing all these podcasts, but like, how does your daily life looks like, and where do you focus most of your time?
Every day is different. No day is the same. After I talked to you just now, it's windy outside, but I will run 4 miles. I didn't have time to run before the podcast, so I will run after. I will code for a bit, maybe later. I spend a lot of time with my team, a lot of time with my company. We're building the company right now. There's lots to do. There's lots to prove. There's lots to change. But the nice thing is I'm only trying to do one thing. I'm trying to understand what life is. To do that, I need to create a technology for chemistry. That's my company. That's non-negotiable. I have to create that technology. I have to help people make molecules, discover new drugs, discover new materials. That's part of the thing we need to do with what we've developed. And on the other side, I need to build the team in my research group for understanding complexity, developing the chemical code for building the machines, for understanding reactivity, understanding how chemistry becomes complex. And then the other thing I'm becoming interested in is how the brain computes with chemistry. And so what I want to do is like solve the origin of life, if you like, with my collaborators, create a programming language for chemistry to build drugs and make a really big company that can change people's healthcare outcomes, design new molecules, help global warming, do kind of powerful things with chemistry. And then I want to understand, what is it about the brain, the chemistry in the brain, that makes the brain this AGI? Because we are not going to get anywhere near any AGI or anything. So every day is different. I'm interacting with people, different problems every day. I'm very privileged that I have an enormous number of very gifted people that I work with. I have a very supportive company. I have a very supportive university. And somehow I still have funding, right? And so that's kind of important too.
You said in the beginning that you are trying to do one thing, but then you explained so many different things. I'm curious how all connect, if you can tell.
They all fit together. They're all about understanding chemistry using technology and harnessing that technology. I think, the company and the origin of life are the same thing together. They're the absolutely same thing. I have to do both. And it's kind of crazy to explain to some people. They just don't get it, but it's actually the case. Some of the algorithms I'm writing for origin of life are using in drug discovery, because you can't just use normal AI in drug discovery, because the AI that we're building right now doesn't work. but the understanding how chemistry became complicated in the environment created life. And if we can understand that for drug discovery, I reckon we can discover drugs much faster, that are much better, that are much more safe, and we can do it. We just have to do this more quickly. Chemists, and we have to have the robots to do it, right? And that's what my company has to do, is like to kind of really make sure that encoding is reliable and so on. And we're kind of in a big race, right? There's people that don't really realize they're in a race yet. We just need to. So I can't say too much. We're in a race. We're going to win. We're winning. We won.
We won. I'm a bit curious about the financial side. So from the beginning, you had funding from other people to start this. You are making some money with the project as well, so it's self-sustaining, or is mostly funding from external stuff until you have some discoveries? Like, how does it work?
So I have three types of funding. I have grant funding from governments, lots of different governments around the world. The UK obviously is a very strong funder in my university. And that funding is spent on research. In my research group, hire students from all around the world, postdocs, interns. So part of that funding is used for training, discovery of technology, and asking questions. I also have funding from charities to take some of the technology, maybe do something new that maybe help somewhat developing world, maybe ask questions we can't normally ask within the confines of grant funding. And then my company has been invested in by investors who want to grow the company to solve a specific problem, right? Where there's a market. And so the company obviously has to find partners that are willing to pay to kind of further their own commercial requirements, as well as human health, human desire for new materials, new technologies. And so there's lots of different funding streams, but they're the kind of three principal ones: grants, charity, investors. And it's very important to keep those separate and to maintain the barriers, because the company is about investing in technology, investing in the people in the company, and really trying to make a difference to the world of chemical industry and drug discovery. And that's what it's going to do. Just the research in the lab, there is some technology development, but it's about understanding the origin of life, understanding who we are, understanding where we came from, understanding where we're going, and training people. At the end of the day, you have to train people. We don't have to, but it's really the most delightful outcome of academia if done correctly. You have all these incredible people that come and help you solve problems, and before you know it, they are more competent, more curious, more brave than you are.
How do you train people? Do you have any tips for training people?
Yeah. Give them problems and not lectures. Problems are the way to problems with critical feedback are the best way to train scientists. Do not try and teach them. And I'm a bad teacher. But I make good problems.
So you are a good teacher.
I'm not qualified to comment. I mean, I'm lucky. I've had I don't know, probably I've had about 350 people come through my team in the last 20 years, and and they're everywhere. There's I think 70 professors, and teachers, people in industry, people starting new companies there. So there may be some of them aren't quite as crazy as I would, hope they should be. But the problem is that maybe it's hard to be crazy sometimes. Get cancelled, get no money, annoy everybody.
But sometimes there is a book, I think, only the crazy survive. There is a quote, only the crazy survive. So
maybe. I mean, I think there's a balance, right? I try and teach the balance.
So you said you hope. You said that you are going to do it. You are going to win the marathon of doing a lot of these discoveries. So you said that if a lot of things go right, you're going to maybe come up with better how to not age, how to solve the climate stuff, and all this stuff. Can you touch a bit more uh, on the optimism? How do you feel about the future, like with artificial intelligence, with the climate problems that they? I don't know if you believe in the climate problem, because some people don't believe in the climate
Oh,
problems.
I mean, I think belief, people who believe things do
Yeah,
not, can't falsify them. I mean, I think,
I love you.
I think there is sufficient evidence to indicate the planet has been warming. Now, I don't know how much evidence there is to say it's a massive problem, right? Or if it's a problem that of the existential threats that we are saying, right? I haven't seen much evidence of that, right? But I am worried about water security, food security, people mobility, right, in the world, to make sure that we've got this population on the planet and everyone has food, has water, has decent shelter, have things to do, you know. But yeah, I'm an optimist. I think that climate change is a necessary product of our generation of knowledge. No climate change, no knowledge. So now it's a race. We're in a race to create enough knowledge to fix climate change. So I think we should actually burn more carbon more quickly if we're going to give that knowledge to people to generate fusion, for instance, right? Actually, just as a preface here, I have no idea what I'm talking about. This is just my personal view, but I think it's interesting. I'm sure there are climate change people and energy specialists that know better. But if you burn fossil fuels faster, so let's say you've got all these people and you say, slow down, stop eating meat, stop traveling, please feel guilty about burning fossil fuels. Oh, how you should feel guilty about buying a new jacket, you know, feel guilty. These poor people just feel guilty. But really what we want is we want people to create new knowledge, solve a problem. Now, actually, the only way we're going to solve global warming, is to remove CO2 from the atmosphere. We don't have enough energy, right? There's not quite now. We don't have enough energy. But where we could have enough energy is if we made fusion work quickly. So one idea would be to say, okay, everyone who's working on new energy technologies gets to burn as much carbon as they want. Quick, get to zero. You want to 0.1 cents per kilowatt hour of electricity now, and storage. So that's one idea, right? An optimistic idea. Let's just make sure we get there and we replace. You know, we won't burn all the oil in the ground because we'll quickly get.
And how we get there? You said you are going to probably consume more on the way.
Yes, we need to. We have not yet got the technology. We need to refine lithium. We need to get enough deuterium and tritium. We need to build superconducting magnets. We need to trial and error, get the metal. We need to build the grids, build the batteries. But once we have access to that energy and we get exponential growth of fusion on the planet, we'll be able to then take the CO2 out of the atmosphere through a standard chemical process powered by electricity. That's what we have to do. And so, you know, I won't necessarily solve that. I mean, but if I can do something to help that, you know, by designing new materials, you know, that's one contribution. You were talking about aging. I mean, I think aging is okay, right? You're not going to stop aging immediately, but you should be able to help people live a longer health span. And sure, it's a super hard problem, but we should be able to perhaps reprogram some cells at some point, which will make a difference. And I'm convinced that some of that programming will have something to do with chemistry. So, you know, chemistry holds the answer. I would say that I'm a chemist, right? We will live forever, have infinite energy, and understand aliens because we are chemistry.
That's why you'll believe that chemistry is sexy.
Exactly.
So, do you think we should live forever?
I want to. I don't think living forever is necessarily a good thing, but I'm not sure I have an opinion, right? I'm having fun. I don't want to stop having fun. So I don't have any strong opinions either way.
So, okay, you believe that we're going to solve all these problems, climate change. Also, to touch a bit on climate change, to finish, close the loop there. So you are basically kind of believe, you are not sure if the evidence, if we are going to be destroyed by climate change, but you're saying there is no reason not to fix the climate change if we are so technological advanced and we progress and all this stuff. So it's just...
Yeah, I
And
would say it is essential we fix climate in the long term. There is nothing good is going to happen if we keep putting CO2 in the atmosphere. Have we hit the trigger point, this point, that point? I don't know. As an optimist, I don't think we had a choice. We had to burn coal. We had to burn oil. We have to get to fusion. We are not going to live in caves and not burn any fossil fuel. Let's get to fusion. There's nuclear fusion and nuclear fission and renewable energy as quickly as possible so we can then deal with the mess we've made. And this is what's happened in all technologies. We make a mess, we clean it up. We make a mess, we clean it up. I don't think we are doomed. I think humanity is going to be on the planet until we have the real climate change when the sun becomes a red giant. And that's in a few billion years. And that we have to plan for.
So optimistic, wow.
Yeah, there's no reason not to be. People are living, there's more people alive on the earth than ever. There's more people living longer. There's less people dying. I know right now there's a war and it's really outrageous. Hopefully, we're going to find a way through the suffering to remove future suffering. And so nothing excuses suffering in the present. We should act to minimize suffering in the present. And I'm hoping from what's happening right now in Israel and Gaza and Ukraine and various other in Africa, that we will start to act to minimize suffering, and we will realize the act of violence against another human being is the most outrageous thing we could ever do. And I think that there is no excuse for violence ever. We need knowledge and fun and not violence and misery. And it is in our gift to make that happen by generating more fun for each other and working out where the most negative things are in our human nature and solving them. Give people enough food. Give people enough water. Give people enough education. Give people enough, I don't know, social media. Maybe not social media. Yeah, I think we're going to be fine. I think the future is completely to play for, and I think we should stop being miserable. And I think maybe there's some financial transitions the planet has to go through. But I'm not an economist. I'm not a philosopher. I'm not a very good physicist, but I like chemistry.
So you touch a bit on every time when they ask me what's the meaning of life or why you're doing all these things, I just say because of fun. But a lot of times people ask me, well, if it's fun for a pedophile to like abuse children, like should he do it? And like you touch a bit on Palestine and Israel, like is it fun for Hamas or Palestine because they are feel oppressed to do this behavior, and the other way around for Israel to do this to Hamas? Like, where do you stop? Where do you draw the line?
None of that's come about through fun, right? So the paedophile thing, there's a couple of things there. I'm not qualified, but my guess is people exhibiting those socially unacceptable and culturally unacceptable behaviors that cause damage to other human beings maybe is from some kind of brain damage, trauma, right? So that may explain that. And we might look at it one day to say, oh, someone is ill in the same way if you have schizophrenia or something, right? I don't know. when it comes about, I don't think that terrorists or any people in a war think it's fun. I think they absolutely have a cause and they think it's life or death. So there's two different things there. So, with regards to kind of abuse.
Well, you don't think your cause is life or death to solve this problem that you're trying to solve?
So I think they're differently expressed, right? I think I have no concept of what it's like to live in Gaza. I have no concept of what it's like to live in fear of attack all the time, every day. I have no concept. So things I have no concept on, I try not to tell people my opinions. I try to instead listen to people who have those concepts and try and learn and try and figure out. But I think it's not unreasonable to expect that we should try and strive for no war, no aggression in war. And I think it's probably not unreasonable for us to try and understand, to try and aim for no child abuse of any description. Minimize child abuse, minimize war. That's two nice things to kind of aspire to, I guess.
I was asking you more on the fun kind of context where you draw the line. So yes, I was not asking your
fun
opinion, but let me rephrase what you said. So you said fun until it's not harming other people's lives.
There's a moral framework, isn't there, right? We have these moral frameworks in which we exist as human beings. And those moral frameworks are shared by most of society. There are some members of society who don't have those moral frameworks. They're a problem, right? So, yeah, I mean, some people could say, hey, Lee, you're burning all this fossil fuel, traveling, doing all this research for your fun. You're causing damage to future generations. And I would say, well, what we need to do is we need to work out what's happening in the current generation and make sure we're generating enough knowledge in the current generation to help future generations. So my moral kind of foundation is more on the basis of generating knowledge and using my freedom, which I have been given by my past generations, to do that. Now, I mean, I'm not really qualified philosophically to think about, what happens if you're in this particular type of hedonistic approach. But I think it's possible to create opportunities through this idea of, having fun in the universe. I don't think, some people might think it's fun to kill other people, right? I don't think there's many people who share that. If you think about what it means to you, if your loved one is killed or you die, there is no universe where that's fun. It might be fun to play a computer game where you're shooting fictitious entities and you're trying to win. That might be fun. But I think that if you are able to have an absolute understanding of the moral dilemma, then certain things that could be fun are really not fun.
Should we? Because a lot of times, I don't know if you found that when you say fun, a lot of times people misunderstanding, because fun means a lot of different things for different people. For example, some people, so maybe we should switch this word with curiosity.
Yeah, no, I use curiosity much more than fun. I mean, for me, it's like, I totally agree. I mean, I have fun being curious. That's a nice way to do it. And also that curiosity that doesn't come without any moral burden. The same way having fun doesn't come without moral burden. You can say, oh, I was curious. I got these human beings, I trapped them and I did experiments on them because I was curious. Well, that's not that's against our social norms, our cultural norms. We don't want to be captured, right? So but anyway, in chemistry, the way I'm doing chemistry, doing drug discovery, looking for the origin of life, probably the harm I can do is limited, but it doesn't mean I shouldn't be anticipating. Maybe I make a molecule that's dangerous, poisonous. Maybe I make a life form that could be aggressive. So, I think about these things as well. Innovation is not without risk. But you know what? There's a much bigger risk. if you don't innovate. So, open innovation de-risks innovation, because if you're not doing it, someone else is behind closed doors, because human beings are competitive. Their Darwinian instincts makes them compete. It's kind of very illogical to the degree that, well, not logical, it's completely understandable.
And maybe they are the bad guys or something.
In the future, our cultural norms are going to shift. I mean, you need to think about, what are you going to be cancelled for 20 years from now, what you did now that's totally fine. Maybe in 20 years, we're going to all look at each other. The children in 20 years will say, you've burned fossil fuels, you're terrible. Or you didn't make new nuclear reactors when you had the chance. Or you didn't do X, right? I mean, it's very easy. I have very few I don't think that way. It's kind of, I can't second guess.
But it's a good framework to go 20 years from now and think what you should be, kind of put in perspective what you should be doing with your life.
No,
now.
I don't agree.
No?
Because the future is intrinsically open and unknown. If you do that, it's become more pessimistic and you limit the number of things you can do. My job is to create opportunity and knowledge. That's it. That's all I have to do. If I create opportunity and knowledge through my life, then I will leave the world with more possibilities and more knowledge than before I came. And then I have done my job as a human being.
And you have free will as human?
I think that's an ill-posed question.
Meaning?
No one has free will. But I have will, and I use it.
So you don't think we have power over our choices?
No, I didn't say that. I think we do have power of our choices. But free will, what does free will mean? Random will? The choices I make are a product of my past. They interact with my game engine in the present, and I'm imagining the future. And that's different. We don't know what that is yet. That's novelty, right? I don't know.
So basically how you describe it is we don't have too much, because we have the past that we have the psychology that we have now, and there is very limited the stuff, if there is any stuff to choose. We have so many limited of outcomes, or not.
No, I think you have a huge amount of choice, but your agency is something you exert over a long time. And also, the most agency you have is basically how you remember your past and how it makes you feel. That's what you have most control over. Because how you remember the past and how you feel about the past can actually actively help you think about how you're going to do things in the future. I think that's super important to bear that in mind as well. But I don't know. I think I have will. I don't know how free it is. I'm autonomous. I'm not deterministic in that regard. There are things I can do. On the world, and things I can't do.
Where do you stand on the mind-body problem of consciousness?
The mind emerges from the body, and it's all materialistic, but there are some missing gaps.
The mind emerges from the body, and it's all materialistic. Okay, so you are a physicalist, straight physicalist.
Yeah.
You need to be as a on your field, right? You are studying all this physical stuff.
I think so, yeah.
So I'm just taking your takes on a lot of interesting topics now. I don't know if you understand. So you mentioned artificial intelligence before. And you mentioned that you find stupid for people to predict when AGI will happen, because we never had this before. So, you think it's stupid to predict the singularity?
Yeah, there's no singularity. They're only sigmoids. What is a singularity? There's going to be no intelligence better than the human brain. Or let's put it another way, there'll be no intelligence that can think of things the human brain can't think of. Human brain is Turing complete. It can do things maybe a little bit more slowly, maybe we'll have added, but the human brain, AGI is not going to have some magic access to reality we don't already have. It's just there's no physical mechanism by why that is the case. It's kind of just made up fantasy. It's so funny how books, like Nick Bostrom wrote this book, Superintelligence. It's a well-written book. I liked reading it. It's not grounded in any argument that I have any relationship with. That's me trying to be as polite as possible.
So you think all this AGI, AI talk is nonsense?
I think all this talk that we have an impending AI doom is absolute, complete stupidity. What we do have problems with immediately is verified data and authentic users. We need to make sure we're interacting with authentic users and we verify our data. And that will allow us to get around deep fakes and disinformation. But that's nothing new. Disinformation has been around for ever since the advent of our culture. This is nothing new. So this AGI stuff, AI stuff is nonsense. Yes, ChatGPT is super interesting. There's stuff going on we don't understand, right? But that's because it's not going on in ChatGPT. It's going on in the structure of human language. Consciousness emerged over populations of human beings exchanging symbols. Consciousness did not spring up in one brain. Consciousness sprung up, I think, over a collection of minds and then became compressed into individual minds because we share symbolic reasoning. And ChatGPT is showing us how that happened. And we're just like completely in love with it because it's like kind of interesting. But there is no artificial intelligence yet. There will be. There is no physical reason why we can't build one. It may be infeasible, it may take a long time, but all this talk of AI and AI doom is actually, I think, pretty offensive to those of us that are trying to solve real world problems right now. Help stop people from dying from cancer. Help stop people. Because if I'm not allowed to use an AI because of some stupid nonsense and it might discover a new molecule that can be used to treat cancer, I mean, what is that? It's like because a load of people who couldn't think properly stopped me using matrix multiplication in a certain way. Stop abuse of data. Stop abuse of fake bots. Perfect. But there's no AI problem.
Well, I consider myself stupid. I don't know what I'm going to talk about, but a lot. But from me, my observations, I got convinced that when you don't know how one person with all the data in the world, if you put in your brain all the data in the world, what you're going to come up and what you're going to be able to create, and so this to me sounds scary, and like what they are saying about all this stuff and what you're going to be create. So what is your answer to this?
I think that there's nothing to be scared of but fear itself, right? You know, what's going to happen with all this data? Because everyone keeps going about AI getting control of nuclear weapons. Who? Where is this entity? Where are the thoughts? Where are the goals? It's nonsense. Goals evolved over 4.2 billion years, right? Basically, the consciousness that is on planet Earth right now, as known in humanity, is the sum total of 4.2 billion years of survival. When we create an AGI, or an artificial general intelligence, it will be complementary to the human brain. It will be connected to the human technology. It might outlive us. It might outgrow us. but it's not going to destroy us, right? Unless there's a natural series of events going to happen, we're looking at it the wrong way. Human beings are going to evolve beyond the current form. Do we think that human beings will be like this in 4 billion years? I would be quite depressed if human beings just had 2 arms and 2 legs in 4 billion years. I'd like something more. I'm kind of joking. I can't conceive of it. But what I'm saying is, all the data, what is all the data going to give you? Human beings are great reasoning machines. We're great cultural machines. We're a lot more than data. And we don't know what we are entirely. We don't know how the brain works. We don't know how about the origin of life. We don't know about the origin of consciousness. So there's so many interesting things to look at. But what I'm saying is the tech guys and a few untrained philosophers are just making stuff up because they want to point themselves to new religious leaders. And what you see right now is the emergence of new religions. AI doom, AI optimism, right? Religions are captivated by the same mystery and fear and lack of explanation. And if you can't explain to me how I'm going to die from this AGI, I'm probably not going to die. There's more chance of me dying when I go out running in a minute and it's windy and a tree blows on me or something.
Well, I love how honest and straightforward you are. This is really... So I have 2 last questions. First question is, I ask everyone in this podcast, I give you $1 trillion. How do you spend it to maximize the good impact in the world?
$1 trillion? I'd love to spend it on my origin of life and chemify and make drugs. But really, if I had $1 trillion right now, I'd spend it on getting to fusion as quickly as possible and making sure that energy was distributed to every human being on planet Earth.
Wow. Okay. And are you ready for the last question?
Sure.
This will be, this is how we close the podcast with all the guests. So this is, you are going to die in couple of years or whatever. And we want to come in this clip, this last 30 seconds, and we want to hear what you have to broadcast to the world. Let's say now you're going to die in 30 seconds. What you have to say in the world. This is your last message. And like, if this happens in 20 years from now, we can come back and look at your thoughts in these 30 seconds. So are you down to do that?
I would say, look at the last hour and a half, what I've said, and think about how I would think about the future. Make an optimistic chatbot based on Lee. You can extract lots of information from the last 1 hour and 32 minutes. Have fun with my ideas.
Okay, thank you for your time. I love you. Thank you for watching, guys.